Hello dear students, welcome to E-Pathashala. I am Vimala, Assistant Professor, Department of Commerce, Avinash Lingam Institute for Home Science and Higher Education for Women, Coimbatore. Today I am going to discuss about probability distribution. So let us have an introduction about what probability distribution says. So probability distribution. In the 17th century, the theory of probability was developed. The concept of probability was first developed from throwing a dice, games, tossing a coins, drawing a card from a packet. In the year 1954, Anthony Godban took an initiation to develop the probability distribution and made this area as a more interesting among the statisticians. In our routine lifestyle, the term probability or the word chance generally used. For example, or for instance, we say probably tomorrow the climate may be very hot. Probably Miss Vasanti may come for party today. And probably you are right. These terms of possibilities and probability express the same sense. But in statistics, the probability has certain unique connotation unlike in the normal layman's outlook. Now let us understand what the definition says about the probability distribution. Probability distribution is a distinct condition of the principal sample space with a set of all possible results of the random occurrence of happenings or occurrence of events which is generally observed. The sample space with the set of real numbers or higher dimensional vector space and non-numerical values are considered here. For instance, the sample space of a coin flip will be either head or tail. So the probability theory proves, that is, it provides a means of getting an idea of the likelihood of occurrence of different events resulting from a random experiment in terms of quantitative measures ranging between 0 and 1. The probability is 0 of an impossible event and 1 for the event which is certain of occurrence of the event. This is all about the definition says. Now let us understand in detail what the probability distribution deals with. Okay. The probability distribution are the record of all the values of random variables. Here the variables are assumed as that is corresponding probabilities to create a probability distribution. Random variable doesn't mean that all the values are different type or anything which is experimental study. These random variables are well explained with a set of results along with the well distinct probabilities for the happening of each outcomes or result of the explorative study or any research outcome or a result. Here the term random refers to the facts or statistics that the outcome happens by the chance of occurrence of the event. This can be well explained with a suitable example. For instance, the probability distribution which results in rolling of a dice in solo performance. For example, it is discussed in detail above the table. Look at a table. The table 1 shows very clearly if a single fair die is placed, how it is going to be represented. Say in a die it includes in 6 different connotation, probability of the x may differs from 1/6. So total the sum of probability may be 6 by 6. So it may result in 1. So always the probability may be the positive occurrence will be 1 if the negative occurrence will be 0. So it can be better understand with the help of mean, variance and standard deviation. To understand this probability distribution, it is very important to understand mean, median and variance and standard deviation. So this can be very clearly explained with the help of the following table, that is following symmetrical representation. From the following it is very clearly specified that how a population or a sample of a study can be distributed systematically. Here the definition for the population mean and variance are well defined for both the used ungrouped frequency distribution. So you can look at the formula, it says very clearly mean. So mean is equal to sigma x function x of that is mean is equal to sigma, that is sum of x function divided by n, or standard deviation is equal to sigma x square function minus sigma xf to this, that is whole square divided by n whole divided by n. This formula explains what? That is taking the population as a n. The n population is divided by the population variance, the sample variance which was fair estimated for the population variance. This can be divided by n minus 1, that is sample n minus 1 for the computation purpose. After this process, you can use the algebraic formulas or any equations to understand more effectively. This equation can also be equivalent to another equation. Look at this equation. It says that mean is equal to sigma x into f divided by n, that is events divided by number of population, or standard deviation is equal to the sum of x square into f divided by n minus sum of that is x into f divided by n whole square. That means this formula says that to recollect the probability or elongated terms to relative frequency distribution. So every frequency represented by f and population represented by n. So frequency, that is a function of frequency divided by n, can be replaced by f. The function of f can be replaced by p, that is probability, and p, n can be represented by the n. So it is represented like probability of x. That means the function of n is represented as f, that is probability function of x. This syntax can be more simplified. So look at this formula, that is simplified form of the probability distribution. The mean is equal to, that is sum of x into p. X is a here population, p is a probability, the sum of population probability function of x. This says that simplified formula to calculate the mean when we are discussing the probability distribution. And look into next how we are going to calculate the standard deviation, the sigma x square into, that is probability function of x, that is x is a population minus the sigma x into p into x square. So this is a simplified format to calculate the mean, median and under the probability distribution. To understand this formula better, okay, so two formulas are used. So for greatest portion of the variance in the mean square calculation, look at the above formula here. So here mean is equal to, that is sigma x p, that is sigma x into p to the power of x, and standard deviation is represented like standard deviation is equal to, that is sigma x square p into x minus, that is mean square. Okay, the above two examples is worked out in table 2. Just have a glance about the table 2, how the probability is distribution in the same case when a die is thrown. Okay, when you die, you are going to throw a die, the probability of x, n times you are throwing the dice, so probability may be 1/6 in each time. When 6 times you are throwing, the result may be 1. So the same when you are going to get the standard deviation, it will be 3.5, and the square root of the standard deviation will be 15.17. Okay, this is detailedly calculated. Have a glance at the calculations. The mean is x probability, x function of that is probability function of x is equal to 21 divided by 6, that is 21 times the probable distributions is possible. The variance will be computed as follow, that is probability function of x minus x to the power of 2 into probability x. So it results for 2.9. okay, the calculations. The standard deviation of the same thing will be represented by 1.7078. So we can say that the probability distribution is a mathematical or arithmetical or numerical or statistical or geometrical function which can be stated in a very simple way to make it very easier to provide the various probability of occurrence of the events or different possible happenings of the events in any experiment. This can be better understood with the help of the diagrammatic representation. The probability distribution can be represented in a bell-shaped curve. That is, just you look at that. The mean, median, mode is how we are going to depict in a pictorial format. In more methodological terms, the probability distribution is a narrative of random happenings of event which is represented in a pictorial way to understand the probability of occurrence of the events. The probability distribution is narrated in a bell-shaped curve with a unimodal peaks at a single value. It is a symmetrical where one side is of mirror and other which is mentioned with a mean, median and mode in a bell-shaped curve. So mean equal to mode equal to, that is mean equal to median equal to mode. So this probability distribution is symptomatic of both the left and right side of the normal bell-shaped curve. So x-axis with the width determine the quantum of the amount with the variance of the random variables. This is not replaced by the standard normal distribution in a general form. This is a continuous distribution also. It can be derived from the binomial distribution as a limiting case where n is represented. The number of trials in a very large sample, say x and p, the probability of success is close to the half. The general equation is called as a function of x is equal to 1 divided by root square of that is root of mean to the power of 2, that is fx, the function of x is equal to 1 divided by root of 2 pi to the power of that is sigma x. Let us understand in detail where the variables x lies between the infinite population may be greater than, that is may be greater than or less than the mean. So here mean and standard deviation are called the parameters of the distribution. For example, it is represented as a f function of x. So it is called as a probability distribution function, or it is also called as a normal distribution. To calculate the normal distribution, we need mean and standard deviation. So it can be represented in the graph of the normal distribution. When we represent the same thing in a graph, we call it as a normal curve. In a bell-shaped and symmetric, both its mean, the two tail of the curve extended to the infinite and finite curve in a unimodel. The total area under the curve will be 1. This can be better understood with the help of an example. Now let us have an example how we can prove this probability, normal probability distribution with an example or normal curve. So a coin is tossed 3 times. Find the probability of getting 2 heads and a tail in a given order. Say for example, when you are tossing a coin for a 3 time, you have to get 2 times head and you have to get 1 time tail. So what is the formula you are going to use in n probability distribution? Means here n combination x into p to the power of x into 1 minus p to the power of n minus x. This is the standard formula we use to calculate the normal probability distribution by using a mathematical way, where n represent the total number of trials, x represent the number of successes, p represent the possibility of the success. Let us understand one by one how to determine the possible results. So first step, you have to determine the n combination x. That means to determine the number of ways of success can be occur. The second is you need to find out the p to the power of x, that is probability of getting x success. And third step, you have to calculate 1 minus p to the power of n minus x, that is you have to find out the probability of getting the n minus x failures. So now let us have the solution, how we can get. So first is you are going to toss 3 times. That means n, the number of population or number of probabilities may be, you are applying for 3 times, n is equal to 3. So your result you have to get 2. So that is head you have to get 2 means let us assume head as a x is equal to 2. So probability of head will be half, probability of tail will be half, because we know that probability should be equal to 1. So when head and tail is there, head will be half and tail will be half. How we are going to get 2 head in the 3 times toys? That is probability of 2 head is equal to 3 combination of 2 into half to the power of square. The same formula you are applying, you will get the normal distribution, normal probability function, that is 3 by 8. Okay, this is all about normal curve, normal probability distribution function. Let us understand another important aspects under the normal probability distribution is normal random variable or normal distribution, we can call it as a normal distribution. So this normal random variable or a distribution can be described as a continuous random variables. It can be better understood by 2 predominant ways which is represented below. Number 1 is density plotted in terms of shape. So density, always the probability density will be plotted in terms of bell. That is, we are going to represent in the symmetric centering at a mu. That is a bell shaped curve. We are going to, the center portion of the symmetry will be the mean. Okay, and the mean should be equal to either median or mode. Either it may be the left side, it is represented the, that is negative mean values, and right side it represented as a positive mean. From the above plot, we should clearly and fully specify the 2 parameters, that is mean and the standard deviation. When we are plotting the diagram, it is very important to understand the 2 parameters. One is mean and the standard deviation. The distribution is denoted by n into mean and standard deviation and shown that as a standard deviation in terms of variance of the x. It is called as a standard deviation of x. Okay, this is all about normal distribution. So under normal distribution only we have another aspects, that is standard normal distribution. What is this standard normal distribution says? This normal distribution with the mean 0, that is mean is equal to 0, and the standard variation is equal to 1. It denotes n. N either may be 0 or 1. Normally we use for the n z to denote a standard normal random variable. It is very important to note that for whatever the purpose we learn or understand, the standard normal distribution is very important. To calculate the area under the normal curve either numerically or geometrically, many statisticians have established the tables to indicate the left tail area and the right tail area under the standard normal curve. Okay, so of any given number. Here the probability distributions are an elementary model in a statistics. They are used both on a theoretical point of view as well as practical point of view. Okay, this is all about the normal standard distribution or a normal standard case. So let us understand now the discrete probability distribution. What this discrete probability distribution says about? It is applicable to the current scenario where the set of possible outcomes is discrete, such as a coin tossed or roll of dice can be encoded by the discrete list of the probabilities of the outcome. It is known as a probability mass function. Now let us understand continuous probability distribution. This continuous probability distribution to the scenario where the set of outcomes can be taken on values of continuous range. Say for example real numbers or such as the temperature on a given day is typically described by the probability density function only, with the probability of any individual outcome actually being 0 or 1. The normal distribution is commonly encountered continuously as a probability distribution. This is about the discrete continuous probability distribution. Now let us understand the normal, that is a random variable. What is this random variable? It is a variable those values is determined by the outcome of the random experiment. The random variable whose value is determined by the outcome of the random experiment is called random variable. For example, this is the income of a random selected family. For example, a random variable, say x, is said to have the normal distribution with a parameter, that is mean and the standard deviation. Its density function is given by function of x is equal to 1 divided by square root of 2 pi standard deviation. So either it may be minus 1, either it may be a 2. It depends upon the definite population and indefinite population. It can be shown that expected E is equal to expected value is equal to either mean or variance of x is equal to standard deviation. The normal distribution is characterized by the mean, that is mean and the standard deviation. Now discrete random variable. A discrete random variable is one whose set of assumed values is countable. For example, arise from counting. Discrete random variable whose values are countable is called as a discrete random variable. For example, number of car in a parking lot any particular time is considered as a discrete random variable. So let us understand what is the continuous random variable. Continuous random variable is one whose set of assumed values is uncountable. For example, arises from temperature. Continuous random variable that can assume any value in one or more intervals is called as a continuous random variable. For example, of the time taken by a person to travel by car from New York to Boston may be vary. We cannot exactly say this much time is going to be taken. So for this is all about the discrete variable. Now let us understand what is the another type of the distribution we call as a very popular distribution, binomial distribution. In a probability theory and a statistics, the term binomial distribution is the discrete probability distribution of a number of successes in a sequence of n independent, say yes or no experiment, each of which yields success with the probabilities of p. Such as success or failure experiments is called as a Bernoulli experiment or Bernoulli trial. In fact, when n is equal to 1, the binomial distribution is a Bernoulli distribution. The another terminologies we use for binomial distribution is also called as a Bernoulli distribution. So the binomial distribution is a basis for the population where binomial test of statistical significance plays a role. For example, this can be better understood with an example. An elementary example is roll a die 10 times and count the number or one's outcome. Then this random number follows as a binomial distribution with n is equal to 10. That means, so in a die you may have 6 different values. So when you throw it for a 10 times, probability may be 1/6. For example, assume 5% of the population is green-eyed. You pick 500 people randomly. Okay, the number of green-eyed people you pick is random variable will be x, which follows a binomial distribution with a n is equal to 500. So probability may be 5%. That's all about the binomial distribution. Now let us have a look at about conditional probability. So what is this conditional probability says? That is nothing but two events, say x and y or a and b. Here the probability of two variables, probability of a intersect b is equal to p function of, that is probability function of a and b divided by the probability of b, where a, that is probability function of a and b means the probability of outcome that events a and b have in common sense. Okay. Let us have another example to understand it more better. What is this exactly says about? When a die is rolled once, find out the probability of getting a 4 given that even number of occurrence in the earlier throw. For example, here the probability of 4 times when you drop, probability function of 4 and an even number. You need to find when you are throwing a die for 4 times, you have to find out the how many time even number it is appear. So it can be represented like probability function of 4 and even number is equal to 1/6. That is the probability of two different aspects a and b is equal to 1/6 of probability even. So 3/6 is nothing but half of the probability. So this is with the help of the probability function of a intersect b is equal to p probability function of a and b divided by p function of probability b is equal to, the result will be 1/6. Just look at the formula how we have been. Now let us understand one more example to understand more better the probability distribution. A bag contains 3 oranges, 3 yellow and 2 white marbles. Okay, the 3 marbles are selected without replacement. Find the probability of selecting 2 yellow and white marble. For the same formula you are going to apply and you will get the result. The earlier formula which we applied, that is P intersect, that is probability of A intersect B, the same formula we applied and we got the result. Let us go for the next example. In a class there are 8 girls and 6 boys. Okay, if 3 students are selected at a random for debating, find out the probability about that girls. So again the same formula, the probability of girls. Okay, in a class you are going to get the result in the same way. Just look at the formulas which have been. We will move on to the next aspects now. So likewise there are so many examples proves how the probability may differ here. So here one more example, say in how many ways can 3 drama officials be selected from 8 members. So for this you have 8 combinations. You can represent 8 combination 3 is equal to 58 ways you can find out the drama officials in a different way. Okay. So next example, let us move on to the next example. A box has 12 bulbs of which 3 are defective. If 4 bulbs are sold, find out the probability that exactly 1 will be defective. We need to find out the defective bulbs. So let us understand probability of defective bulb is equal to 3 into combination 3 combination 1 and probability of non-defective bulbs which is represented by 9 combination 3. So using the permutation combination we are going to use the 3 combination 1 into 9 combination 3 is equal to 252 combinations you will get when you are going to use the defective and non-defective both. So in that 252 you need to find out which is the defective and which is the non-defective. So that 12 combination 4 you will get 495 and defective will be, you will get 295 out of that. So overall you will get the, that is 1 defective bulb and 3 bulbs are correct out of the 495. Okay, so this is all about the binomial distribution, says about 2 different occurrences. Now let us understand the Poisson distribution. Poisson distribution is also known as a discrete probability distribution that expresses the probability of a number of events occurring in a fixed period of time if these events occur with a known average rate and are independent of the time since, okay, the last event. For example, the Poisson distribution arises in many situations It is safe to say that it is one of the three most important discrete probability distribution. Okay, the other two being the uniform and the binomial distribution. The Poisson distribution can be viewed as arising from the binomial distributions or exponential density. If the parameter n and p, that is probability of a binomial distribution, are known, then we can find out the distribution. But when n is large and p is very small, the application of binomial distribution is very difficult. Let x be any discrete variable which can take values say 0 to infinite, 0, 1, 2, 3 to until infinite, such the probability distribution function may be of x. For example, probability of x is equal to n to the power of minus lambda, that is divided by lambda x square divided by x factorial. Okay. So where lambda is positive constant, np is equal to lambda, this distribution is called as a Poisson distribution. Okay. Next, let us understand the example more better. With the help of the example, we can understand what exactly says about this Poisson distribution. Number of printing mistakes on each page of a book published by the good publisher. Wow, that is one condition. Second condition is number of telephone calls arriving at a telephone switchboard per minute. So how, with the help of a Poisson distribution, how we can find out this? So the Poisson distribution is a common distribution used to model, to count the data. The number of telephone calls we receive per hour, we need to count it. Number of claims received per day by an insurance company, number of accidents per month at an intersection. These are the things, example, we use to find out the result, to count the results. With the help of the Poisson distribution, we can find out it. Let us understand some of the major objectives of the, why this objectives plays such an important role. The first objective is to compute and interpret the expected value, variance and standard deviation for the discrete random variables and work with the probability involving in the binomial possibilities. The second objective is to work out the probabilities involving a Poisson distribution, Poisson probability distribution. The third objective is to understand the concept of the random variables and probability distribution. Fourth is to decide the binomial distribution problems to be approximated by the Poisson distribution, to use the Poisson distribution in analyzing the statistics. To use the hypergeometric distribution and know how to work with the problems. These are some of the objectives why we use the normal probability distribution. So we need to follow certain rules. Let us understand the rules in probabilities. The number one rule is called as a addition rule. Number two is called as a multiplication rule. Number one, let us understand the addition rules. Addition rule is nothing but when two events A and B are mutually exclusive, then P, probability of A or B. So it can be represented probability of A plus probability of B. The same example we have already discussed earlier, and we go for the rule 2. Okay. So rule 2 says that if A and B are two events that are not mutually exclusive, then the probability of A or B, probability of A plus probability of B minus P into A and B. Okay, where A and B means the number of outcomes on that events of A and B have been common. When a card is drawn from a packet of 52 cards, find out the probability that the card is 10 or heart. Okay, for example, the probability of 10 is equal to 1, that is 4 by 52, that is we need to find out for heart. So that is 4 by 52, it comes to about, that is 1 by 52, so totally 16 by 52 will be the result. Okay. Next rule we will go for the multiplication rule. For two independent event A and B, probability of P of A and B will be represented like that, probability of A into probability of P. So for example, determine the probability of obtaining 5 on a die and a tail on a coin in one throw. So the probability of 5 is equal to 1 by 6 and probability of tail is equal to 1 by 2. So that the probability of 5 and T, that is tail, that is 5 head and tail, is equal to probability of head 5 into probability of T is equal to 1/6 into 1. So the result will be 1 by 12. So let us understand the rule 2 better. When two events are dependent, the probability of both event occurring is probability of P and P of function A and B is equal to probability of A into probability B intersect A, where the probability B intersect A is probability that event B occurs given with the event has been already occurred. Okay. So same example, one more example, when you pick a card, 52 cards without replacement, so you need to find out the probability. So the result will be again in the same pattern you are going to calculate. Okay. Now let us understand the merits of probability distribution. The merits of probability distribution and the benefits of theoretical or probability distribution are: number 1, where the calculations of observed distribution is not possible, that is one of advantage. Second advantage is sometimes observed based distribution calculation is not at all possible due to impossible at the place we can calculate the probability distribution. The third is, it is helpful in forecasting probability distribution, is very helpful on the basis we can estimate our future and make good plans for our business. And it helps in comparison, it can compare real distribution and evaluate our efficiency of the work. So there are some limitations also. Let us understand some of the limitations, how it is having drawback. Number 1 is, probability distribution cannot be correlated with any event. Number 2 is, probability distribution cannot be viewed in chart form or in any statistical view. Number 3 is, the data cannot be extracted from the probability distribution or cannot include in any reports. Number 4 is, it is excluded from the sensitive analysis or any chart. And number 5 is, the probability distribution doesn't support the Latin hypercube sampling. So to conclude, what this probability says, to summarize the probability distribution, let us it is very important. The probability has become one of the basic tools of the statistic. Sometimes the statistical analysis become paralyzed without the theorem of the probability. For example, the probability of a given event is defined as the expected frequency of the occurrence of the events among the events of a like sort. According to basic economic theory, people wish to maximize their expected utility. In order to do so, they should integrate the likelihood or probability and the possible outcome, say for example good or bad. This means the people maximize their utility based on their perceived importance of the probabilities and the outcome. So in total we can say that probability gives the results of occurrence of the events or outcomes either 0 or 1. The results will be always 0 or 1. So this is all about the probability distributions. Okay. With this I will conclude this session. Thank you.